This is Dr. G. Sarat Raju, Department of Mechanical Engineering. So I am going to dealing with fluid mechanics, under which we have seen different properties of fluids in the previous session. So in this session, we are going to see what is pressure, what are the types of pressures and manometers. The course outcome of this first module is, so relate the basic properties, various types and patterns of the fluid flow configuration that are encoded in fluid flows. So we have discussing about different types of pressures, right? We have been discussing about the fluid properties, under which the other property of the fluid is pressure. So what are the types of the pressures? So pressure can be defined as force exerted on unit area, force by area, force per unit area, Newton per meter square. So Newton per meter square is also known as Pascal. So the SI unit of pressure is Newton per meter square, or it is also known as Pascal. So pressure can be defined as the force exerted on unit area. So what are the different types of pressures? How can you measure the pressures? So first one is atmospheric pressure. So since from the school days also we know pressure is force by area, but atmospheric pressure also we have been known that atmospheric pressure. So that is why atmospheric pressure can be measured with the help of barometer. So what is atmospheric pressure? The pressure exerted by the air surrounding the earth. So generally atmospheric pressure, it can be measured with the help of barometer. So the standard atmospheric pressure at sea level is 101.3 kilopascals or 1.013 bars. So generally and also the other in terms of mm of Hg, 760 mm of Hg. So generally this atmospheric pressure can be measured by using barometer, and its units are 760 mm of Hg, or in terms of water head, 10.3 meters of water we can say. So this is 101.3 kilopascals, or in terms of bars also we can say 1.013. This is also bar is one of the other unit for pressure. So pressure can be measured in terms of Pascal and bar, then mm of Hg, or it can be also cm of Hg, and in terms of meters of water head, 10.3 meters of water head. Like that we can say pressure at we can write different units for pressure. So the first one is atmospheric pressure. Second one is absolute pressure. What do you understand by absolute pressure? So the total pressure measured from absolute zero pressure is known as, or absolute zero means vacuum. So vacuum means if you are removing the air and creating some zero pressure, so that it can be called as a vacuum. So at vacuum or at absolute zero pressure, the total pressure measured from the absolute zero pressure can be known as a vacuum pressure. Then these vacuum pressures are generally measured or taken consideration in case of thermodynamic calculations. So P absolute equal to, in terms of formula, right, we can write P gauge plus P atmospheric. Right. P gauge is pressure gauge. By using gauges, pressure can be measured. So by using some mechanical gauges. So if you observe these cylinders, right, gas cylinders are, right, especially in case of welding, if you observe, there are two cylinders, right, two cylinders. One is oxygen, the other one is acetylene cylinder. So this oxygen and acetylene cylinder, on the top of the cylinder will have one meter, one pressure gauge, which is used to measure the pressure inside the cylinder. What is the pressure of acetylene? What is the pressure of oxygen? Similarly, so pressure gauges, mechanical gauges. By using gauges, we can call it as a gauge pressure. Absolute pressure is the pressure measured at, or the total pressure measured at absolute zero pressure. From the absolute zero pressure, that is from the vacuum, we can call it as an absolute pressure. So absolute pressure, in terms of formula, you can say it is the addition of atmospheric pressure as well as gauge pressure. So gauge pressure. The other one is gauge pressure. Just now we discussed. So by taking two cylinders, or how can you measure the pressure? So in case of even in case of mechanical gauges are there, mechanical pressure gauges like Bourdon 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 tube pressure gauge, and also bellows type. Different pressure gauges, mechanical pressure gauges are there. So the pressure measured with the help of gauges, we can call it as a gauge pressure. So the pressure measured above the atmospheric pressure. Always gauge pressure is always above the atmospheric pressure, right, which is having 760 mm of Hg. So if a manometer or a pressure gauge reads 0, it means the pressure is equal to the atmospheric pressure. Then vacuum pressure. So what do you understand by vacuum pressure? So the pressure below the atmospheric pressure. In the previous case, gauge pressure is above the atmospheric pressure, but whereas vacuum pressure is always below the atmospheric pressure, measured in systems where pressure is lower than the atmospheric pressure. So this vacuum pressure in systems can be measured where the pressure is lower than the atmospheric pressure. So in terms of formula, we can write vacuum pressure is equal to atmospheric pressure minus P absolute pressure. P absolute. So vacuum pressure is the difference of atmospheric pressure minus absolute pressure, whereas absolute pressure is sum of the gauge pressure plus atmospheric pressure. The last one is static pressure. So static pressure means, what is static? So in the introduction I told fluid mechanics broadly classified into fluid statics and fluid kinematics and fluid dynamics. So fluid statics is the study of branch of science which deals with the fluid at rest. The pressure exerted by fluid at rest. The fluid is at rest. We can call it as a statics, fluid statics. When the fluid is in motion, we can call it as kinematics or dynamics. So kinematics is the science of fluids which deals with the fluid when it is in motion without considering the forces. There are no forces. Whereas fluid dynamics dynamics is by considering the forces. So here static pressure means the pressure exerted by a fluid which is at rest. So you and the static pressure is used in fluid statics calculations like hydrostatic pressure in a tank. What is the hydrostatic pressure inside the overhead tank? Then what is the formula for that? The static pressure, because in manometers the generally the static pressure will come into picture. The basic formula for static pressure is rho into G into H, rho G H, where rho is the density of the fluid, G is acceleration due to gravity, height is height of the fluid column that is raised inside a manometer. So pressure, static pressure can be written as P equal to rho GH, rho GH. Then we will discuss what are manometers, what is the purpose of manometer, what do you understand by manometer. So first we have seen what is pressure, definition of pressure and units. Then what are the different types of pressures, how we can measure the atmospheric pressure and other pressures. What are the different types of pressures also we have seen. Now we are going to discuss about the manometers. So manometer is a device which is used to measure the pressure by balancing the weight of the fluid column against the pressure to be measured. So U-tube manometer, we will have U-tube manometer and differential U-tube manometer, differential and inverted differential manometer. We'll see one by one. So U-tube manometer is a device used to measure the pressure by balancing the weight of a liquid column against the pressure to be measured. So one fluid which is having some weight, it will act on the other fluid which may not be mixed with the other. That means two fluids are immiscible. So U-tube manometers are commonly used for their simplicity and accuracy in measuring pressure differences. Differential manometers are either differential manometer or inverted differential manometer. Both will be used for calculating the or for measuring the difference of pressures. Then what are the different types of manometers? First one is simple manometer. Simple manometer consists of a U-shaped tube filled with a liquid. Simple manometer. U-tube simple manometer. This can be connected at any point where we want to measure the pressure. So because of this one, there may be a height. So we can take some datum line, and what will be the raise of fluid in the U-tube manometer. So simple U-tube manometer consists of a U-shaped tube filled with a liquid, that may be a mercury or water or some other oil. One end is connected to the pressure source where we want to measure the, say, some point A, at pressure point A, at location of A, we are going to measure the pressure. So while the other end is open to the atmosphere, that is why this is open to the atmosphere. This is very simple U-tube manometer. So simple U-tube manometer is used to measure the pressure at a single point, and also that point, one end is connected to the point where we want to measure the pressure, and other point or other U-tube is open to the other end is open to the atmosphere. Next one, differential YouTube manometer. So differential YouTube manometer, both the ends of the tube are connected at different pressure sources. Different pressure sources. That means there are 2 points here, like this. So one point is say A, the other point is at B. So differential YouTube, simple manometer is a simple YouTube which is having YouTube, and one end is connected to the point where we want to measure the pressure. The other end is open to the atmosphere. But whereas differential YouTube manometer is connected, both the ends of the tube are connected to different pressure sources. This may be A, may be one pressure source, the other one is B. So used to measure pressure difference between the 2 points. Pressure difference between the 2 points. Simple YouTube manometer is used to measure the pressure at a point, at a single point, a single source or otherwise. Whereas differential YouTube manometer is used to measure the pressure at two different points. Two points. Then what is inverted YouTube manometer? Inverted YouTube manometer. So here, instead of a liquid, it contains air or another gas in the YouTube shape. Maybe two different immiscible liquids may carry the YouTube. So the liquid columns are pushed down due to pressure differences, because of the pressure differences. So inverted YouTube is like this. Here also there are two pressure sources, like this. This is A, B, this is A. Inverted YouTube manometers also having two sources, but suitable for measuring small pressure differences in the gases. So that means a simple YouTube manometer is used to measure the pressure at a single point, whereas differential YouTube manometers are used to measure the difference of pressure between the 2 points. 2 points maybe are at the sometimes maybe same level, or maybe sometimes at different levels. But what is the difference between differential YouTube manometer and inverted YouTube manometer? Inverted YouTube manometer. Differential YouTube manometers are used to measure the pressure at two different points. We'll see problems on differential YouTube manometers. YouTube manometer contains a mercury of specific gravity 13.6 and used to measure the pressure of a gas in a tank. The difference in mercury levels in the two arms is 20 centimeters. Determine the pressure of the gas inside the tank if the atmospheric pressure is 101.3 kilopascals. First, whenever the problem was given, you should write the basic formulas and given data, right? Given data is S of specific gravity of mercury. Mercury is equal to SHG, otherwise you can write SHG equal to 13.6. Then difference of mercury levels in the two arms is H equal to 20 centimeters. Then atmospheric pressure is 101.3 kilopascals, right? So the pressure is, what is asking? Determine the pressure of the gas. Pressure is equal to atmospheric pressure plus static pressure. So atmospheric pressure was given as 101.3 3 kilopascals. So you can write 101.3 kilopascals. Then what is rho GH? Rho of mercury. Rho can be written as rho equal to specific gravity into density of the water, 1000. So you should write 1000 here, right? 13.6 into 1000, 9.81 into point. So it is around 26.6. So it is 127.9 kilopascals. The basic thing you have to remember is the static pressure, just what we have seen in the fifth classification of pressures. So rho GH. Then the other problem on differential U-tube manometer. A differential U-tube manometer is connected to two pipelines carrying different fluids. One arm is connected to a pipe carrying oil of specific gravity 0.8 and the other is connected with the water pipeline. So one arm is connected with the oil, the other is connected with the water. The difference in heights is 25 centimeters with oil in the higher arm. Find the pressure difference between the two pipelines. So there are two pipelines here. One is say carrying oil and this is water say. The other one is carrying say point B and point A. So here in the problem, the other end is connected to water pipeline and one arm is connected to the oil and the difference of heights is 25 centimeters with oil is higher. So oil is higher. That means this is the water. Up to here, this may have water. And from here, you can keep some dots to show the difference. So this is oil, this is water. So what is the difference in the heights is 25 centimeters with oil and higher arm. So that means oil should high. The heights between these two is H equal to 25 centimeters. Find the pressure difference. What is PB minus PA or P of water minus rho of water minus rho of oil. So what is the basic formula? Pressure P equal to, the basic formula is rho into G into H. Here, what is the pressure difference? Delta P say. That is nothing but PA minus PB. PA minus PB is equal to density rho of A minus rho of B. A we are taking as water, B we are taking it as oil, GH. So that is why density of water we know that is 1000 kg per meter cube. And how can you find this? Specific gravity was given. Specific gravity of oil is 0.8. 0.8. How can you find the rho of oil is equal to 0.8 into 0.8 into density of water, that is 1000. So what is the basic formula? Specific gravity. What is the basic formula? Specific gravity of particular fluid is specific gravity of the flowing fluid divided by specific gravity of the standard fluid. Standard fluid is here water. So if you want to calculate the specific gravity, rho of fluid Specific gravity is density of the fluid by density of the standard fluid, that is water. So if you want to calculate density of the fluid or density of oil is equal to specific gravity into density of water. So that is why we wrote specific gravity of oil into 1000 gives you the density of oil. So what is the basic formula? Delta P equal to rho of water minus rho of oil into G into H, right? So rho of water is 1000, that is why we can keep 1000 here. Density of oil is 0.8 into 1000, 0.8 into minus 0.8 into 1000. What is 0.8? Specific gravity of the oil. If you multiply with the density of water, it will gives you density of oil. This is density of water minus density of oil into G. G is 9.81 into H was given as 25 centimeters. You convert into meters. 25 is 0.25 by 100. So 0.25. So 200 in this one. So 200, 9.81, 0.25. So delta P, that is nothing but PA minus PB. Difference of pressures will be 490.5 pascals. That is Newton per meter square. Pascal is Newton per meter square. Or if you want to write it in generally, this pressure can be defined or can be kept in terms of kilopascals. Just you divide with this 1000. So we can have 0.4905 kilopascals. So the other problem for YouTube manometer is a YouTube manometer contains water in the left limb and glycerin of specific gravity 1.26 glycerin in the right limb. So in the left limb we will have water, in the right limb we will have glycerin of specific gravity 1.26. The water level is 25 centimeters higher than the glycerin level. Find the pressure difference between the two sides. Here there are two fluids. Here say glycerin and here say water. Why? He has given the clue the water level is 25 centimeters higher than the glycerin level. This may be taken as water. This is glycerin. So the heights of difference of heights, right? This is say up to, this is glycerin and this is water. So water height may be higher than the glycerin height somewhere here. So the difference of heights, glycerin and water, is H equal to 25 centimeters. So the basic formula again is delta P or P. Delta P is P glycerin minus P water gives you the delta P. So what will be the pressure exerted by water? What is pressure? Pressure equal to, the basic formula is rho G H, static pressure. Rho is density of the, so suppose if you have taken water, pressure of water, so rho of water. So that is why he has taken rho of water. pressure of water will be rho gh, rho of water into 9.81 into h is difference of heights 25 centimeters, but you should convert it into meters. So it is around 2452.5 pascals. Then what will be the pressure exerted by the glycerin? So glycerin will have a specific gravity of 1.26. 1.26. So as I told, this rho of fluid divided by rho of water is equal to specific gravity. So if you want to calculate rho of fluid, here glycerin, rho of glycerin is equal to rho of glycerin equal to S into specific gravity into rho of water. So that is why specific gravity of the glycerin is 1.26 into density of water will be 1000. So 1.26 into 1000. This is rho of glycerin. Rho of glycerin. Rho into G. G is 9.81. H of glycerin. That is so 1000 into 9.81 into 0.25 is equal to 1000 into H of glycerin. H of glycerin we don't know. That's what we want to calculate. So H of glycerin is equal to 0.25 by 1.26. That is around to be 0.198 meters. 198 meters. So that if you convert it into 19.8 centimeters in terms of, so the height of the glycerin column is 19.8 centimeters. Okay. So in the, since the height of the column is unknown thing, right? The height of the glycerin is unknown. Height of the water column is known. So that is why in rho GH, rho is the density of the glycerin, G is acceleration due to gravity, H is H of glycerin, we don't know glycerin. So that's so under equilibrium conditions, rho of water or rho GH is equal to rho of glycerin and G into H of glycerin. Here water. So that is why equate both. You know this value already calculated. So we wrote here 24552.5 pascals. Then equate to the same value here. Right? Equate 2000 something, right? 2452.5 kilopascals equal to 1260 into 9.81 into H of glycerin. So we can calculate H of glycerin, and it is going to be 9.8 centimeters.
Like, share and subscribe. Hit the bell icon for more updates.